so questions like this that you have to do is page 480, number 5 and 9. Okay, we're going to do the intersection today of 2 planes and 3 planes. We're going to say that 2 planes can intersect in 3 ways. And intersecting planes is such a difficult concept that you guys have come here to Mr. Kemp's class before, right? Do you remember how Mr. Kemp used to give you those nice level C questions where you have to make a creative option on your own? And some people loved them, some people hated them. What Mr. Kemp's class, because of that though, is that they've made me some beautiful handouts for you guys for this here. I don't know how many 2 planes intersect. Okay. But again, it's because these are difficult to visualize. So it says here there are 3 ways we can have 2 planes intersect. If my plane, the first plane is going to be the blackboard. The second plane is going to be an imaginary binder. Okay, so this is my second plane, something like this. What are the different ways it's going to intersect with the blackboard? What are the ways it can intersect? Perpendicular. Okay, perpendicular will intersect one. If this binder, sorry, I can seal this by the way. If this plane intersects with the blackboard, what shape will it make as it intersects? A line. Okay, because this binder isn't really a binder. It's actually an infinitely big plane like this. So if you have there is no single point intersection for 2 planes. Right? That would. This is more. Okay. But the idea is though, right? The logic is right when you have 2 planes intersect, and if you don't believe me, take a piece of paper and put it against your book, right? You'll see that it's going to be in a line. So the first way is going to be one intersection, which is the intersection of a line. Can someone explain to me, please, why it's impossible for 2 planes to intersect at a point? Why is it impossible? Go ahead. They're infinitely big, right? Like an infinite space, right? Like it's not like you're just using a piece of paper and you only touch the corner, right? Because this paper goes on forever, right? Okay, so it's not possible to just intersect a single point. It has to be a line. What's another way they can intersect?
Like the paper cut.
What's that? Sorry? Yeah, they don't, okay? So if the 2 planes are parallel, okay, so number 2 is no intersections. Parallel, which would be the same n hat, but not a shared point. Okay. And number 3 would be infinite intersections. It's going to be parallel. And that's going to say same scalar equation. Okay, because the difference between 2 and 3 is if the d's are different, they're going to be parallel but not touch in their scalar form. If the d's are the same, they're going to be parallel and actually touch. So the printing's getting poor. I'm going to try and fix that here on it. Okay. Here we go. I'm going to do 2 examples here, then we're going to get to 3 planes hopefully. Right? So you get the logic here, right? Intersect in a line, intersect parallel, don't intersect at all. Okay? Or sorry, intersect in a line, intersect parallel, intersect infinite. Okay? Here we go, example 2. Okay, please put a star beside this question. Okay, so just do this 50 times and a choice assignment. Determine the line. Well, the last one, I think it was example 1. I think it was supposed to be. It was supposed to be example 1. That's okay. Example 2 says determine the line that the planes intersect. the first one's going to be 3x plus 2y plus 5z equals 25. 4x minus 3y plus z equals 22. Okay, before I go any further, how can I tell that those planes will intersect? Very good. They're different, yes. Like their n hats aren't like multiples of each other, right? So remember the normal. What's the normal of the first plane going to be? 3, 2, 5, right? So 3, 2, 5, and 4, negative 3, 1 aren't related in any multiples of each other. Okay, so that's fine. All right, so we want to find the line of intersection of these. There are many different ways to do this. I'm going to use elimination for a change because I like elimination. Okay, so thinking back to grade 10, and I apologize for the grade 11s when I talked because I said elimination is bad in grade 11. Okay, I said substitution is always better. This is the only time substitution works. Okay, I'm going to deal with substitution on the next thing if you want me to. So the way elimination works, if you remember, is that you want to multiply them by things to get them to cancel out. I'm going to cancel out the y's here. Looking at this equation, why is it probably obvious that the y's are what are going to be what I want to cancel out?
I was gonna say z.
Z's will work too, but what is that? One's negative, one's positive. Okay, that's the reason I'm going to use. You can cancel out the z's, you can cancel out the x's. In order to make the y's the same, Ben, I'm going to pick on you because you seem to remember elimination from grade 10. What am I going to multiply the first equation by? What are you going to multiply the second equation by? Okay, so this is going to be like common denominator, which we're looking for here math-wise. Okay, so can someone other than Ben multiply the whole first equation by 3, please, and tell me what we get? So it's going to be 9x plus 6y plus 15z, and that's a z, sorry, equals 75. Someone else other than Evan, show off their 2 times table of power and multiply the second equation for me, please. Oh, good golly. No one except for Evan knows their 2 times table? Yes, thank you.
8x minus 6y plus 2z equals 44.
Good, thank you. Now, looking at this, I know that Arden and Evan have done this right because you have a positive 6 and you have a negative 6, so they're going to cancel. The way elimination works, if you remember, you just add north-south down the columns here, okay? So 9 plus 8 is 17x, and you get 17y, and you get 119. Oops, that should be a z. Sorry, whoops, thank you. Okay, so I'm going to express x then. Let's solve for x. How do I solve for x? Oh, goodness. Oh, good Lord. How do you solve for x? Go ahead. Isolate, thank you. So we're going to say 17x equals negative 17z plus 119. Hopefully that all divides by 17. Does 119 divide by 17? Hopefully it does. Great. Okay, so now what I have done is I've expressed x in terms of z, which is fine. Can somebody give me a suggestion on what to do next? Good. Okay, so what I'm going to do next is I'm going to sub it into maybe 1. Sub x equals negative z plus 7 into 1 to isolate y in terms of z. Okay, so it's going to be 3 bracket, negative z plus 7 plus 2y plus 5z equals 25. Using my great math skills, it's going to be negative 3z plus 21 plus 2y plus 5z equals 25. Oh boy, 2y plus 2z equals 4. Y equals negative z plus 2. I think I did my math like that. Someone can go from there. All right, so things are looking good, but not yet great. Okay, so I'm going to slow down here because I'm too excited here. I can't help it. I love math. I hear buzzing. You just hear buzzing. problem is I can't do anything more with this. Okay, right? Like you can't combine them and get a number for Z and all that sort of stuff. So what I'm just going to do is I'm going to set, we want a parametric equation of the line. So set Z equals T. Okay. It can be anything you want. I happen to choose it as T. If Z is equal to T, what is that going to make X equal to? 1 minus T. And Y should be then 2 minus T. That's a parametric equation of the line right there. I'm going to make it a vector equation of the line just to make sure it looks, you get it? So my vector equation of the line is going to be 7, 2, 0 plus T, negative 1, negative 1, 1. And there's your solution right there. So this is just algebra, that's all that is. Now I'm going to give you one of these to practice before I move on, because once you do these, like they're not difficult, but you got to do a few of them to make sure that you're feeling good about yourselves. The first step to this is moving everything into scalar form. So if you look on your assignment, I will have a question like this, and I'll give you like points to put into scalar form first, because I'm a cruel human being. Okay, right? But once they're in scalar form, then it's just basic algebra. That's all it is. If you want to use substitution, you may. Okay, right? And isolate and do all this sort of stuff. But for this one, it seems that elimination works a lot better. This is the only time in my life, I'm going to get to matrices tomorrow, that elimination works better. Like for me, well, I don't want to talk for myself. Okay. Are we sort of okay with what happened here? There's just tons of algebra. Okay. So elimination first. Put both put x and y in terms of z. Then just set z equal to some constant, and then it goes from there. Okay. Sort of good, Katie? Sort of well. All right, example 3. You guys try this one, please. Go ahead and pause the video, and then we'll go through it as quickly as we can. Example 3 says, determine the line through which the planes intersect. Equation 1 is going to be 8x minus 4y plus z equals 12. And equation 2 is going to be x plus y minus 5z equals negative 6. Okay, so I'm going to pause in the video. Michael and I are going to come around and see how things are going. I am going to solve this in terms of elimination. If you want to do substitution, you may. Okay, you will get the same answer at the end or something darn close to it. Okay, so, yeah. Not into